Okay, the substitution axiom states if A and B are equal to each other, then A can be replaced by B. Okay, and a lot of people get hung up on the way this looks and they think things have to look exactly like they are. A equals B just means that you have some objects equal some other object. It could look like this. Y equals 3x minus 7. Y is acting like A and 3x minus 7 is acting like B. Something equals something you can replace. So if I have this equation, y equals 3x minus 7, I can replace any y's with the expression 3x minus 7. That's what this axiom tells me. And that's kind of how it's going to be used in the problems we're going to deal with today. And some of you might be thinking right now, why would I want to replace y with 3x minus 7? Why is it so much nicer looking than 3x minus 7? If you have two variables in a problem, this allows us to get rid of one of those variables. Makes the problem easier to deal with. And one extra thing with the substitution axiom I want to bring to your attention here is if you replace one thing with multiple things, you have to use parentheses. So if I'm going to replace one y with 3x minus 7, the 3x minus 7 has to be put in parentheses to be treated as one object. And as far as how to solve a system of equations, they look like this, by the way. Use substitution to solve for x and y. So they're going to have a couple equations. All of these little braces next to it. The equations will contain the letters x and y. All right. If you have a system of equations and you want to use substitution to solve it, step one, you want to solve one of the two equations for one of the variables. You want to get one of the equations, say x equals everything else or y equals everything else. If I recall correctly, every problem we see today is going to already be like that. This step, I think, is already going to be done. If not, it's going to be a one-step process. It's going to be easy to do it. But if I remember right, every one of the problems we have today, they're going to be already set up like that. Step two is the substitution step. If you have the bottom equation that says y equals everything else, substitute into the top equation. If the top equation says x equals everything else, substitute in the bottom equation. Whichever equation is this one, substitute that information into the other one. And just that this way, wherever you see y, change it to 3x minus 7, or whatever it is. All right? Once you've done that, you've only got one variable, solve that equation. If it's x equals or y equals, doesn't matter, you get the answer. Once you know that answer, substitute that in. Like once I get x equals 2, for example, I go here, 3 times 2 is 6 minus 1, minus 7 is negative 1, so y is negative 1. Substitute that in to figure out what the other variable is. Once you know both answers, write your answers in order to pair x, y. If we're considering these are linear equations that make lines, 2x plus y equals 2 makes this line. X equals negative 3y plus 11 would make kind of like this line here. They're going to cross at some point. We're finding the point of intersections. That's what we're finding. All right, you don't have to graph these to do that. So if we just follow through the substitution axiom with this, the substitution technique with this, I want you to first of all notice that the bottom equation already has the structure we're looking for. So step one, it tells us we want one of the equations to say either x equals everything else or y equals everything else. X equals everything else. That's perfectly set up for substitution to work. And the way substitution works, step two is all about substituting properly. X and negative 3y plus 11 are equivalent. What I have circled there is exactly the same as what I have circled there. And notice that x is in the other equation. So I'm going to take the x out of the top equation and replace it with negative 3y plus 11. So if we take a look at the top equation, 2 is being multiplied by x. I'm replacing x with the expression negative 3y plus 11. So 2 times x becomes 2 times this, plus y stays plus y, equals 2 stays equals 2. So the top equation is exactly the same. The only change I made was x got replaced with what x equals based on what the bottom equation tells me x equals. And again, the reason that's a powerful step, the reason that's important to us, the reason we want to do that, 2x plus y equals 2 makes a line. A line has infinity answers. 2 times all this plus y equals 2 has one answer. And the one answer it has is exactly the answer we're looking for. So that's the usefulness of that. We went from infinity solutions to only the one solution we care about. So that's why we want to do it. And then we simply solve this equation the old-fashioned way. I want to get y equals everything else. So first of all, I distribute. We get negative 6y plus 22 plus y equals 2. I'm going to move the 22 over to the other side. Negative 6y plus 1y is negative 5y. Subtraction because the signs are different, and negative because 6 is bigger. 2 minus 22 is negative 20. Subtraction because the signs are different, and negative because 22 is bigger. And if negative 5y equals negative 20, we divide both sides by negative 5. That leaves me with y equals 4. So that's the step where it says solve for the variable that remains. So once I replaced x with negative 3y plus 11, y remains. I went ahead and solved, figured out what y equals. So as far as my answer is concerned, I'm looking for an ordered pair. The y coordinate of that ordered pair is 4. Okay, I also need to know the x coordinate of the ordered pair. And that's where I take this y answer and I go back to this expression. This y equals 4, so that y equals 4 based on the substitution axiom again. This is a true statement. Y and 4 are equivalent to each other. This y can be replaced with 4. So I'm left with x equals negative 3 times y plus 11, and y replaced with 4. Negative 3y means negative 3 times y, so I want to replace y with 4. These are being multiplied. Negative 3 times 4 is negative 12. And negative 12 plus 11 I'm subtracting because the signs are different. It's negative because 12 is bigger. X equals negative 1. Just like that, negative 1, 4 is the solution. If I were to graph two lines, that's where the two lines would intersect.